So once again, I want to welcome all of you to the Valley of the Shadows of Management Science. We have been looking at linear programming, how to model linear programming. And this assumes that most of the variables are not decimals. They are not fractional. They are non-integers. But what we are going to do right now is to look at integers. Why? Because there are certain things in life that are not decimals. For example, you cannot have 38.56 aircrafts. Neither can you have 401.18 vehicles. And the temptation is that most people, when they get to this situation, they want to round off. But when you round off, you will come across problems. Let's take an example of a rounding off. Let's say that I have $4.24 billion. When you round it up to the nearest whole number, what is it? Who can tell us? Nathaniel.
Okay, so please, when we are rounding up to the nearest whole number, I'll get $4.0 billion.
So in short, you get what?
4.0.
Why did you leave the point? In short, you get what?
$4
$4.
Hey, you pay it.
4 billion.
4 billion.
4 billion.
Yes, dog.
So you get 4. You see, everybody is correcting you because you were not focused. So you get $4 billion. That's what you get, guys. And that means that you've thrown away how much? I think this person hears us after 1 minute when everybody has heard us. Please, class rep, the essence of you being a co-host is to mute people talking by heart when I haven't called them. Okay. So you get $4 billion, and that means that you have thrown away a certain amount of money. Philip, what have you thrown away?
Yeah, you have thrown away $240 million.
That's a point. Rounding off will have problems. So we need to find a way to handle this rounding off situation. How do we deal with that? How do we handle that? We introduce an integrality constraint. It's the same as linear programming, but the integrality constraint, when you go into the Excel, you see it as int. And there is also a binary constraint. We are going to learn integrality and binary constraints for today. Please have your pen and papers ready. An integer is a positive or negative whole number. That's an integer. A positive or negative whole number. But because of the assumption of non-negativity constraint in linear programming estimations, we will not talk about the negative whole numbers. We'll be dealing with the positive whole numbers. So there are 3 types of integer linear programming problems. The first is a pure, the second is a binary, and the third is a mixture of the two. Let's take a story to demonstrate what this is. Let's assume, for example, that you have this story in front of you. Agbala. Agbala is an owner of a machine shop. Agbala wants to expand the buying of some of the machines, okay, which are the presses and the lathes. These presses and lathes are not in decimals. So for example, if you're talking about a car, you cannot say 4.7 cars. So these presses and lathes are whole numbers. Each press will cost or will increase profit by $100 a day. Each lathe will increase profit. Just use some of these things to guide. Each lathe will increase profit by $150 a day or cedis a day. The number of machines can be bought, that can be bought is limited. It's limited by 1, the cost of the machine, which is the budget, as well as the floor space. The machine and the prices and the space requirement, all of these are shown down here. You can see them here. Remember that the price of the press was, the profit of getting a press was $100, and that of the lathe was $150. So let's first define the decision variables. Who can tell me what a decision variable will be? This table is enough. What would the decision variable be? Raise your hand and tell me. Of course, every time you have to bring the unit of measurement. But these are easy. So what would the decision variable be? Let's pick an anonymous person from the crowd. Yvette Liar. Yvette Liar. Guys, pay attention. Where is Yvette? Normally, when I call some people and they don't respond, usually they are not even by their computer. There you go. Confirmed. -5. Let's go to Dennis Frimpong. That's right.
Yes, so Doc, the decision variable will be let X1 represent the number of press to buy, and let it to be the least represent the least number of the number of presses to buy. That is the X1.
The number of presses.
Okay. X1 represent the number of presses to buy, and
Okay.
S2 represent the number of leather to buy.
The number of what? Leads. Is that right?
Yes, the number of leads to buy, yeah.
All right, okay. Yeah, that's how you got to define the decision variable. Good. Let's go to the objective function, which starts with Z max. Who can tell us how the objective function must be written? Objective function. Remember, the information needed. Are we maximizing or minimizing, by the way? Evelyn. Evelyn, I think your network has a problem. Let's go to another person. Michael.
We are maximizing.
Good. So what will be the objective function? What is objective function?
So Z max is equal to 100x1 plus 150x2.
Good. This is it. Subject to two constraints. The first is the budget constraint, okay, which is a purchase price. And then the second is a floor space constraint. Let's deal with a budget constraint. What would the constraint be? You can tell me. Raise your hand. Everything is on your screen. What would the constraint be? What would the constraint for the budget, the price? Nathaniel.
So say please, the constraint for the budget to be 8,000 X1 plus 4,000 X2 less than or equals to less than or equals to 40,000.
Good. Who can tell us the floor space constraint? The floor space constraint, what will it be? Let's go to Michael Ahmeda.
Yes, Doc, it will be 15x1 plus 30x2 will be equal to will be less than or equal to 200 feet square.
Okay, what gave you the idea that it's not equal to but less than or equal to?
Okay.
What is in the sentence that gave you the clue?
It says that's the available floor space.
Very good. At least you got it. So this is it. And then you add one more constraint. What constraint would that be?
Non-negativity.
I didn't call you. Okay. You add one more constraint. What constraint would that be? Class rep, be useful. Okay, because that's what I made. What would be one more constraint? Evelyn. Yes, Evelyn. No, I think your network is bad, Evelyn. You should find a way to check it. Maybe log out and come back in. So you get this non-negativity constraints, okay, which is x1 and x2 greater or equal to 0. But you must also indicate the integrality constraint. How do you write that? After you've written the non-negativity constraint, you bring a comma and just say and integer. And integer. This is cool. Okay. So what you are saying is that the x1 and the x2 must be positive whole numbers. That's what you've said. And that's it. So this is how you do the formulation. That's it. Let's look at the final result of the model. This is it. This is it. So know how you incorporate the integrality constraint. Let's look at the next one. The next one is going to tell us what kind of model we got to deal with. And you have to always think when you're modeling integer constraint, because you know they are going to be whole numbers. You know that. But sometimes it can also be a type of a whole number. Who can read this story on the screen for us? Ask questions. Chidi.
Legon Council must decide which of 4 recreation facilities to build. They have to choose among pool, tennis center, athletic field, and gymnasium in such a way as to maximize daily usage by residents. The expected daily usage, cost, and land requirements for each project are in the table below. LC has $120,000 budget and 12 acres of land. Because swimming pool and tennis center must be built on the same part of the land parcel. Only one of these two can be built. LC wants to know which facility to construct in order to maximize the expected daily usage by the residents.
Good. So this is the information, the data that you have. So watch this carefully. This is very important. And in integer programming, you got to understand and watch it carefully. All you got to do in an integer programming to score your 25 mark is just modeling it. You don't solve it, model it. Model it. That's it. You don't solve it, model it. So in this story, you got to make a decision to build a pool, a tennis center, athletic field, or gymnasium. What you see here is expected daily usage. That's expected number of people who will use the pool, the tennis center, and then the rest. What you have here is a budget for building each one, and then the acres of land needed for the construction. Now, what are the decision variables here? And you got to decide on what the decision variables are here based on your understanding of the information that was given. What are the decision variables? You can raise a hand and tell us. Let x1 be what? Let x1 be what? So you can raise your hand. Everybody should raise his hand and answer a question today at least once. Once. Because I'm recording this and I'm going to use that to reward you. It's called class participation. Margaret. Bright. Bright angle, or it's not right. Okay, Sylvia.
All right, so let X1 be construction of swimming pool.
Okay, if you say that, it's not correct. It's not really correct. Okay. And normally the only way you can say that is because you probably read the slides before coming, but that part was deliberately written in such a way that you will say it like this, and then I'll tell you it's wrong. There is something in this story that should guide your thinking process when it comes to what to write. First of all, there is something in this story that tells you that this is a binary element. Class reps, do your work. Okay, it tells you that this is a binary element. What is that? What is that? Michael.
Hello, Doc.
Go ahead.
So we can say let X1 be the cost of building. Let X1 be a construction of only the swimming pool.
No, that shouldn't be it. Daniel. Nathaniel's line is gone off. Okay, Sylvia. Okay. Michael Ameuda.
Doc, that was the old hand. Sorry.
So can you all do me a favor so that you lower your hand immediately you have spoken? Okay. All right. Frederick.
So Doc, we'll say let X1 represent the size of swimming pool to construct.
So guys, there are some few things you got to know. There is something in the story that should tell you that you are dealing with a binary decision variable. Write it down. You are dealing with a binary decision variable. A decision variable that can go either way. There is something, there is a word. There is a word that tells you by dealing with a binary decision variable. And a binary decision variable is a variable that in itself can go both ways. So first of all, what is that word? That tells you that you are dealing with a binary decision variable. This is important. And as a
Prof. Doc, the word is choose.
Choose, very good. Or decide, also from another angle. Okay. So this word was very, very explicit, and that word below it is also very important. Now, that's the first thing. So it means that for each variable, we've got to make a choice to do what, and a choice not to do what. That's what I want to know. A choice to do what? Michael.
You let X1 represent the choice to construct a pool.
And a choice not to do what?
Or X1 represent the decision to construct a pool.
No, you got to give me the choice. Okay, see, I explained it, Jennifer. See why?
I think it is let X1 be the choice to construct a swimming pool.
Okay. You see, when you're telling me a choice to go to college, you can't just say that. It's always in comparison with something. A choice to use your money to go to college or not to go to college with your money. There's always two things. The word choice means I got to mention the two things you are choosing from. So we will not stretch it. Okay, so the X1 is whether or not, okay, or let's put it this way, whether to construct a swimming pool or not. That is what you are doing with. Whether to construct a swimming pool or not. That is the X1. It's not just a construction of it, but whether or not to construct, which in that case, it will have a value of, if you are going to construct, then you are going to have a positive value for it. Okay. Well, let me put it this way. No, if you're going to construct, yes, you're going to have a positive value for it. And that positive value will be what value? You can tell me. If you're going to construct, you're going to have a positive value for it. And that positive value is going to be what value? Philip.
Say 1.
And when you are not going to construct, it's going to have what value? Philip.
0.
Okay, so that shows that X1 is binary. The same way X2 is binary. Okay? So it's going to be 0 or 1. X3 is also going to be binary after you've explained what each one of them means. So it's a choice of whether to construct it or not to construct it. That's what we mean by the decision variable. Question? Okay, next. You got to write your objective function. So first of all, let's decide, are we maximizing or we are minimizing? And whichever one it is, what are we maximizing or what are we minimizing? You can tell me. What are we max or minimizing? What are we maximizing or minimizing? Chidi?
So we're maximizing daily usage by the residents.
Good. What is that?
Usage of the facilities that they are choosing to build.
Okay. So what does that mean? Is it a human beings? Is it cost of the, what is that? Raymond?
Of the space.
The space. No, not really the space. Guys, what are we maximizing? Isaac Yawamankwa.
People per day.
We are not measuring the people per day. No. What are we maximizing? Is a usage. What usage? The number of using the thing. So a person can still come and use the thing 4 times. He can come and swim 4 times in the day. So you can't say that we are measuring the person, the number of people. No. But the number of times people are going to use the space. That is it. And they want to maximize the usage. So 10 people can come and use the whole thing, not 10 times. But can come and use it maybe 50 times. It means each one may have come 5 times of the day. All right, so keep that in mind. That's what we are going to maximize, the daily usage. But you got to understand in principle what you mean. When you speak of some of these things, it's critically important that you know exactly what you mean. Now, we need to write objective function. And in writing the objective function, we need to use the information in the table here. So which of the columns are we going to use to write our Z-max? Which column are we going to use to write our Z-max? Before I come to the Z-max. Nathaniel.
Please, you are going to use the cost column.
Okay.
So you are going to use the cost column.
So give me the first one for the X1 variable.
So the first one will be 35,000 X1.
Okay. I wanted to be sure that's what you meant. No, that's wrong. What is going to be our objective function? Anna.
Please, we use the expected usage, people/day.
Why?
Because the number of times the people will use the facility is what we are looking at to maximize.
Good. So that's very good. So what will be the first, information?
300 X1.
Very good. Very good.
Plus,
so the lady has.
Should I continue?
Hold on. You continue. Hold on. I know you are itching to continue. So guys, remember, it's not just usage, but it's expected usage. So now you can continue. Plus what?
Okay, 300 X1 plus 90 X2 plus 400 X3 plus 150 X4.
Okay. So this is your objective function. Who can tell me, what does this value mean? First of all, what is the difference? What is the difference between the 300 and then the X1? What is the difference between the two? Before we combine them. What is the difference between the two? What is the 300 and what is the X1? This is where wisdom is at play. Chidi, is your hand still up?
Yes, sir, but I have a question.
Go ahead.
So I think in a previous slide, I saw X2 0 or 1. I don't know if you mentioned something there too, or you are saying that X2 is 0 or 1. In the previous slide where you wrote, where we were
the
writing.
definition, maybe you were lost because you weren't paying attention. Because if you saw only that, it means that you weren't paying attention with the rest.
No. I'm not saying I saw only that. I'm saying that I realized that you wrote, after you wrote X1 to be whether to construct the pool or not, and then you wrote X2 0 or 1.
I know.
I just wanted
but
to
there was a
know if you were
sentence
explaining
accompanying that 0 or 1. That's what I mean by that sentence. Maybe you didn't write the sentence down.
Yeah, you mentioned that the one there was someone that responded would represent that there should be a construction of the swimming pool. So that's
the 1 means that you are constructing it. The 0 means that you are not constructing it.
Okay.
That was the essence of the 0 or 1. So you either construct, which is 1, or you don't construct, which is 0.
Okay,
and
I wanted to clarify.
Goes the same way with that of the others. All right. Now, who can I answer me? Pamela.
Okay, so I'm just going to try. The difference between the 300 and X1 is X1 will represent whether to construct the pool, and then the 300 will be the
when
frequency.
You say whether, you have to finish.
You
can't just say whether to construct the pool and then you leave it there. Whether always has to
whether
continue
to construct
with
the pool or not.
Sorry?
No, I'm getting feedback.
Okay, repeat. Repeat what you said.
Okay. I'm saying the difference between the 300 and X1 is 300 is the frequency, that's the expected usage per day. And then the X1 is whether to construct the pool or not.
Okay. What then is the 300X1? What is the 300X1?
300X1 will be the expected frequency if they decide to construct the pool or not.
And what is the 300?
The 300 is expected usage.
And then the 300X1 is what?
Expected usage and expected usage when they construct the pool.
Hey, yeah. I can see the way you are meandering the words together. It's exciting putting the words. What does it mean to you? How will you explain that to a 7-year-old child?
Okay.
Because what you are doing is that
300.
you are explaining them mathematically in your mind. But what does it mean here?
300 means that the expected number of times we would want people to use the pool when it's constructed.
Give me an example of what you just said.
Okay, so let's say University of Ghana pool, and then we expect people to come in and use it at least 300 times in a day. That means one person can be there, but maybe go into the pool about 4 or 5 times. So a combined total of all the number of times that people use the pool in a day should be 300. Okay, am I on the right path?
And then continue with the other one.
And then the X1 is whether the university decides to construct the pool or not.
Okay, so
So
that
if there is
X1.
no pool,
Mhm.
okay. So if there is no pool, that means that 300 will be the expected usage for whatever they decide to use the space for,
So
instead
then,
of construction of the pool.
so what is a 300x1 combined together? What is that? All right, you've done well. At least you've spoken something. Let's go to Yvette.
Hello, sir.
Yeah.
This 300x1 is the total expected usage for using of the swimming pool.
No, there's
Or the
nothing called
usage of
total expected usage for using the swimming pool. I know what you're saying, because we always talk about profits. So your mind is on the total profit and then the individual profit. But that's not really what this one is, because this is not about profit. So let me see whether somebody will crack it. Erica.
Yes, sir. So the 300x1 will represent the total revenue they are going to get.
No, it's not a total. Somebody just even used total when I'm saying not total. And you are now changing the whole thing to revenue. It's not revenue. It's not revenue. Okay, those of you who are accounting, you should be able to tell me this. I'm now giving you the clue. Those of you are accounting students, you should be able to tell me. If the 300 deals with expected daily usage, daily usage, then the 300x1 will be what? I've given you the clue now. Michael Ameuda.
Is the expected number of people who will go to the pool, should it be constructed?
No. Then Michael Mohammed.
So I think is the number of people expected whether or not to build, which means that they
No, that's not it. Samuel, listen to Samuel. I think he's going to crack it. Samuel, don't disappoint him.
The total daily usage.
No. Barbara.
Sir, is it the actual daily usage?
It is the actual daily usage. I just hope that you didn't say it out of, out of, out of accounting knowledge, theoretical knowledge, but out of understandable knowledge. So what is the difference between
Yes,
expected daily usage and then the actual daily usage? Now tell us.
Okay, so the expected is our projections, but the actual is the exact number of people who would use this the exact usage of the swimming pool if it is whether it is constructed.
So the actual depends on what? You've done well. The actual depends on what? She cracked it out. Chidi, the actual depends on what?
The actual depends on the construction of the swimming pool.
Exactly. So the actual depends on the construction of the thing. So the actual is possible only if x1 is equal to 1. x2 is equal to 1. x3 is equal to 1. x4 is equal to 1. That is when we now know the actual. Once these values are equal to 1, then we now know the actuals. Of course, the actual is still going to be the expected. All right, the actual in this context is still going to be the expected if the decision variables are 1. But it's also not going to be the expected if the decision variables are 0. And that is why you got to distinguish between the two. What is expected is not exactly what is realized. Okay, so this is the objective function. Now let's go to the constraint. The first constraint should be the cost constraint, because that's there. So we've handled this one already. Okay, this next constraint is the cost constraint. Who can walk us through all the cost constraints? Who can do that quickly for us? This one is fairly simple now. It's a mistake. Who can tell us the cost constraint? Esther Bani.
So with the cost constraint, it will be 35,000 x1 plus 10,000 x2 plus 25,000 x3 plus 90,000 x4.
Okay.
Greater than or equal to, I think it was 120,000 or so.
Okay, that's wrong. Who can correct it for us? She says greater than or equal to 120,000. In fact, if you want me to show you, this is the situation here. So why is this wrong? Why is what she said wrong? Anna.
The sign, it should be less than or equal to.
Why? Why should it be?
Because the $120,000 is available.
Thank you. So this $120, because it's the available, okay, this value will not be greater than, or it will be less or equal to. Fantastic. Then let's go to the next constraint. The next constraint is going to be the requirement, the land requirement constraint. So who can quickly walk us through that, Samuel? The land requirement constraint.
Oh, is the old hand.
Dansoa.
Doc, it's 4x1 plus 2x1 plus, sorry, 2x2 plus 7x3 plus 3x4 less than or equal to, I think the total acres was 12.
I'm taking my 12 because I wrote 12.
No.
What if I'm wrong?
You are right, because the 12 was available.
All right. So now we're done with these two. What is the next constraint you need to add? Who can tell me? What's the next constraint you got to add? Michael.
Yeah, Doc, if you read the problem, it's mentioned that swimming pool and tennis are being built on the same land.
Okay.
So you cannot build all two. So we have x1 plus x2. It says you have to choose, the two are being built on the same land. So we have, you either build one of them and not build the other. So we have x1 plus x2 should be less or equal to 1.
Okay. So that is called contingency constraint. Okay. So it says that a swimming pool, which is x1, and a tennis center, which is x2, can be built, but not both. Can be built, but not both. The word or here means you have to do what to those two. The or means you have to do what? Esther?
It means you have to choose one of them.
So what do you do mathematically?
One will be, either one will be 0 or 1.
Yeah, I guess. Let's drop it there. Let's go to the next person. Michael.
You are adding x1 plus x2.
That's it. So you are adding. Okay. You are adding. So it becomes x1 plus x2. And then according to them, okay, it says that can be built. Can be built means what? The word can, not must be built, but can be built. The word built here means what? The word built means what? Philip.
The word built means represents 1.
Good. So the word built is 1. Now the word can be built. Can is what symbol? Can here is what symbol? And of course, I'll ask you why. So think about a why before you turn. Ernest. Then
less than or equal to.
Why?
Because the can implies it's 0 or 1. So if it's built, then it means we go with 1. So either the construction of either of them shouldn't exceed 1.
Not that either of them shouldn't exceed 1, but the construction of either of them.
Yes, Doc.
So the construction of either of them should not be more than 1, which means it can only be 0. The word can means that you can also not. Can is positive or is presence. Cannot is absence. Okay. So good. So that's supposed to be less than or equal to. What if it has been, swimming pool or tennis must be built? Swimming pool or tennis must be built. How will it be? Michael. Anna.
To be x3 plus x4 should be equal to 1.
No, it won't be that. Anna.
Sir, it should be equal to.
What should be equal to?
X1 plus X2 should be equal to 1.
That's it. Okay. Must be built means that your X1 plus your X2, okay, should be equal to 1. So guys, you got to know this thing. This is what you will get in the real market systems of examination. This is what you get. Let's go to another kind of constraint. Okay, this is the one we just did, which is a multiple choice. Now, suppose you have this constraint. Of course, there's another constraint you have to not forget, which is a non-negativity constraint. Okay. Non-negativity constraint. You should not forget that. But apart from the non-negativity constraint, there's another constraint you should not forget. Who can tell me? Apart from this non-negativity constraint, there is another constraint you should not forget. What is that? Michael.
Yeah, x1, x2, x3, x4 should be equal to 0 or 1.
Good. And since this one has already been written as that here, which is the non-negativity constraint, all you got to do is to add and binary. That's all you should add, which will reflect what you said, Michael. Because once you say and binary, you are saying that the x's can be 0 or 1. That's what you're saying. Can be 0 or 1. Fantastic. So this is what we do to do the construction. That is how you actually execute.
Doc, please, I have a question.
Please go ahead.
So I want to find out, are you saying we write the non-negativity constraints and then we write x1, x2, x3, x4 equals 0 and 1 as a constraint also?
No.
Or the non-negativity constraint doesn't come in here?
When you write it like that, non-negativity constraint doesn't come. But when you write the non-negativity constraint, you cannot write this. You just have to add and binary.
Okay, so you are saying you either write a non-negativity constraint with a greater than or equal to 0 and add and binary, or
Correct.
you write this.
Correct.
Okay, thank you.
Okay. Now we move on to the next things. Let's look at some of the possible constraints you could have had. Okay. Suppose the constraint has been exactly 2 of the 4 projects must be built. Exactly 2 of the 4 must be built. Exactly 2 of the 4 must be built. How will you write that constraint? Exactly 2 of them must, of the 4, 2 out of the 4 got to be built. What sort of way would you write it? Now, first of all, you got to note the 4 constraints. What are the 4? The 4 of the constraints, the 4 constraints are x1 plus x2 plus x3 plus x4. Okay, these are the 4 constraints. Now the question says exactly 2 must be built. Must is equal to, and it says exactly 2. So you indicate 2 at the end. That is exactly 2 must be built. What if it had been at least 2 of the projects must be built? What will it be? At least 2 of the projects must be built. Priscilla.
Will be greater than or equal to 2.
And then, if it will be greater than or equal to 2, we expect it to be what? You can tell us. If it is greater than or equal to 2, we expect it to be what? Or Priscilla, you want to tell us yourself?
No, please.
Yes, Anna.
An integer.
I like the way you laughed afterwards. So if it is greater than or equal to 2, it means that the answer could be 2, 3, or 4. That's what it means. Because the maximum number of projects is 4. Okay. So there are only 4 possible because it's greater than or equal to. The equal to will include the 2. Then you have the 3 and 4. So note some of these things, okay? Note some of these things. That is how it will be. Okay, let's look at another constraint. Oh, that's what we just did. Oh, if it had been no more than 2 of the projects must be built, it will be less than or equal to 2, no more than 2. Okay, let's look at this contingency, this co-requisite constraint, dependency constraint. Okay, suppose you are told that swimming pool is very important, just like tennis is also very important. But the thing is that swimming pool is more important than tennis. What kind of constraint would this be? Swimming pool is important, tennis is important, but swimming pool is more important than tennis. What constraint is that? What constraint is that? X1, which is a swimming pool, is important. X2 is also important, but X1 is more important than X2. That's right. No. So this is supposed to be X2 is less or equal to X1. Or X1 is greater or equal to X2. And the reason is because the X2, which is the one that is less important. It's not unimportant. It is important, but it's less important. Okay. So that becomes greater or equal to in this case. You should learn how to. Okay, guys, there was a guy who was telling me that he is fully ready, charged. You know, he would dismember the whole thing. That guy, what's his name? Red.
Doc, I'm here.
You're still around,
Doc, I'm
right?
here. Yes, please.
You are cooking the jollof with me, aren't you?
Yes, please.
I love that. I love that. Stay on track. Never lose hope.
What at all?
You will get to your promised land. Okay.
Amen.
Okay. Now, what if swimming pool should be built if and only if tennis must be built and vice versa? What would it be? Swimming pool should be built if and only if tennis must be built and then vice versa. Michael.
X1 equals X2.
Perfect. Okay, so that one is fairly simple. It means that the X1 is equal to X2 because all of them are the same. That is it. So you got to know that there could be situations like some of these things, but the most important thing is that you don't forget that you are dealing with a binary. This is a final constraint. Okay, the other ones were just ways to show you how to be. But remember, this is a final constraint. Now you can see that here, another trick is that I brought greater or equal to 0. Then in that case, I need to indicate n binary. Dennis, you have a question?
Yes, Doc. Please, the exactly 2 must be built. We had x1 plus x2 plus x3 plus x4 equal to 2. So I want to know if we have been asked to convert it into standard form. And you made mention that less than or equal to, we introduce slack, and greater than or equal to, we introduce surplus. So what happens if we have an equal to sign?
Less than or equal to, you introduce minus, you know. That's what you're saying.
No, I said less than or equal to, we introduce slack. That is when we are being asked to convert to standard form. And greater than or equal to, we introduce surplus. So I'm asking if the sign is equal to, what happens?
Yes, but both of them, the word slack and surplus, both of them you use S1 or S2, right?
Yes.
Yes. So when you are using S1 or S2, remember, all you got to do is to add plus S1 and then equal to the 2 that you have. You're not going to change it because at the end of the day, if there is ever any slack at all, okay, that slack must be added. I've not solved the model, so I wouldn't know. That slack must still be added to the left-hand side before it will be equal to the 2. I believe that that slack is going to be 0, by the way. What I'm saying is that if you're not sure of what slack it is, you're still going to use the equal to sign, the plus sign.
Okay.
Yes.
Doc, what I want to establish is, are we going to use a slack or a surplus? Because
that's what I'm saying. You can't tell whether, you see, there is no guarantee of the choice of a slack or a surplus. Okay, it is a symbol that you are using to replace. Because remember, when you say, are we going to use a slack or so? A slack has a meaning. A slack is a leftover, right, of something. Now, when there is no leftover of that something, that slack is what? 0. Okay, and then the surplus is the overuse of something. So something in which you're supposed to use a minimum requirement. So let's say that you are preparing cake. You are told to use 6 cubes of sugar. That is the minimum required cubes of sugar you should use. Else, if you go and use 2, you have spoiled the thing. So in this case, you decide to use 6. So in this case, the surplus is 0. And in the other example I gave you to, the slack will be 0. So that is why I'm saying that in this case, what do you use, slack or surplus? It's not meaningful to say what do you use, but what symbol are you going to use to represent the condition under which? So please know that the mathematical situation that is happening now, you don't know what the story is about. Unless you got to know, are we dealing with, what are we dealing with? Are we dealing with, you know, things like labor, in which we don't have to go beyond? Or are we dealing with things like, say, sugar, in which we don't have to go below? You get a point? It's a story that will tell you which one you're going to use if the value is 0. I hope you get it. Don't, what do you call it? Don't take it like it must always be a slack when there is a less than or equal to no. Or it must always be a surplus when there's a greater than or equal to. It comes from the story. It comes from the storyline. And therefore, when there is an equal to, you know, what if there is no slack? That's what I keep saying to you. What if the left-hand side is the same as the right-hand side? Then what is the value of slack? Is 0. Okay, now, in terms of surplus too, what if the left-hand side equals to the right-hand side? Then what is the value of the surplus? It's also 0. So that's why I'm saying that you cannot use the fact that slack is always going to be, you know, when it is less than, it must be that. But it is in the context of what you are discussing. That's how we define the slack. Let's move on. The next thing now I want you to do is to go and watch this video about Nancy. This is a mixed integer. And you will see that there was a bit of it that was bound. This is a result of it. A bit of it was non-negativity constraint. A bit of it was integer constraint. A bit of it was, what do you call it? A bit of it was also binary. And I think a bit of it was also decimals. okay, decimals. So you should know that you can have all of this. But that's not my focus here. My focus today is to look at a fixed charge problem. Guys, please, whatever you are doing now, I want you to take some water and sip it into your throat. I implore you to do that for me. Okay, in just 30 seconds, just do that for me. Take some water, drench it into your throat. Take some liquid and execute it into your throat for me. Do that for me.
Hello, bro.
Please, you can talk without showing
Prof.
yourself. You can talk without showing yourself.
Please, my line is breaking, so I couldn't hear what you just said. If you can repeat it again.
Read me. Are you there? Read me. I said drink water. Drink water. That's what I said. I said drink water. All right. Let's start. Guys, pay attention, I beg you. So I want you to remember something you did once upon a time in economics. Okay. Once upon a time in the history of economics, you did something that I'm about to show you here. So please watch. That thing you did, it was under cost curves. Just as a reminder, the cost curves is giving us cost on the vertical axis and then quantity or output on the horizontal axis. And there are three kinds of cost. The first cost is the fixed cost. The second cost is a variable cost. And when you add these two costs together, you get total cost. So the first cost is a total fixed cost, then the total variable cost, and then that leads to the total cost. How do you define the fixed cost? The fixed cost, if it is 100, it is said to be independent of the level of production. What that means is that you can be producing 10, the cost is still fixed. You can increase your production to 30, the cost is still fixed. You can increase production to 100, the cost is still fixed. Fixed cost is that sort of cost which has been incurred already, whether you produce or not. A typical example is rent. So if you pay your rent for a year, whether you stay in the house or you don't stay in the house, the cost is already borne. If you pay for an airline ticket and the airline realizes that 200 people have paid for the ticket, and so the amount of food they budgeted for was 200 people. But then during the check-in, they realized that only 80 people came for the flight. That means that the 120 people's cost of food and everything has already been incurred. The airline will have to bear that cost. And that is why they do some non-refundable tickets, or they will only give you a certain portion of the ticket because they don't want to bear all the cost. Fixed cost is that sort of cost which is independent of your level of passenger or production. The other cost is the variable cost. That one starts from zero. That variable cost rises when your production is going up. So it depends on your production. As your production is increasing from 10, okay, to 30, that cost will also rise from 10, from 30 to say 200. Ladies and gentlemen, what we are going to discuss today is called a fixed charge problem. And it is the same as a fixed cost in microeconomic theory. This is an introduction. Now, to understand the fixed charge theory, you need to beautifully follow me as I walk you through a practical example. It is through the example that you'll be able to catch the real rhythm of this. Remember, example is more efficacious than precept. At any point in time, when you feel you don't understand, you want to let me know, because that is the only way I can actually come to your level and then baptize you in the sea of good management science. Let's begin on how to execute this fixed charge. Somebody should do the reading for us with this beautiful story. I'll use this story to rekindle your mental gymnastics. Who will do the reading? Someone.
Tema Textiles Limited, TTL, manufactures 3 types of clothing: shirts, shorts, and pants. The manufacture of each type of clothing requires that TTL has suitable types of machinery available. The machinery needed to produce each type of clothing must be rented at the following rates: shirt machinery, 200 Ghana cedis per week; shorts machinery, Ghana 150 per week; pants machinery, 100 Ghana cedis per week.
Good, let's continue.
Sir, please, you've not wrote.
I've moved to the next page.
Manufacturing also requires the amounts of clothes and labor shown below. Each week, 150 hours of labor and 160 square yard of clothes are available. The variable unit costs and selling price for each type of clothing are shown in the table below. Formulate an integer programming program whose solution will maximize TTL's weekly profits.
Good. So you have the data here. Okay. Please mute yourself. You have the data here, and the data is made up of labor costs, labor hours, cloth yards, then the type of clothing. You have the sales price, the variable costs, and all of that. There's a lot of information, but let me just give you some beautiful thing about the fixed charge and the integer programming here. Fixed charge always carries an integer program. And it's the fact that this is usually something that you will not have to solve it in an exam. This is usually something that you will have to just formulate, and you have your 25 marks. Finish. That's cool, isn't it? You just have to formulate the model, and you have your 25 over 25. You see, it's not like the linear programming one. The linear program, you have to formulate the model, then an Excel sheet will be given to you, then you have to make sense of every detail of the model. Now, this is different. Let's try to understand the story. First thing we want to establish here, ladies and gentlemen, is that we need to quickly think through. Anytime we read any linear programming problem, we've got to think through to see whether it is dealing with integers or it's not dealing with integers. Who can tell me from this story what shows that this story is dealing with whole numbers or integers? Who can tell us? What gives you the clue? Or what not gives you the clue? It's one thing to know, it's the other thing to teach what you know. So what shows that this, because, and I'm just mentioning it because we are in the world of integer programming. So what is in this that gives you the clue that, yeah, this is about integers? Isaac.
Okay, Doc. So the story is talking about manufacture of shirts, shorts, and pants, and we cannot have an incident of 1.5 shirts, or whether it must be a whole number.
Super. That's it. You cannot have 2.74 pants. It doesn't make sense. So we expect that those variables are going to be whole numbers eventually. That's what we expect. Let's start with the first step in linear programming, whether it's linear or integer. And the first step is to write your decision variables. What are the decision variables here? You can tell us. What are the decision variables? What gives you the clue? What is the decision variable? What are we deciding on? What is TTL deciding on? What are they going to decide that they are going to do something with it, of it? What are they deciding on? What is the decision variable? What is that? Let me call on anybody at all. Let me give it to Josephine J. Ephraim. Squadron leader Josephine J. Ephraim. Are you there? Are you there, Josephine? Let me take note of this. These are people who join my class and they just leave it.
Sir, please, I'm here, sir.
-5 for actually toying with me.
Okay, Doc. I'm here.
Next person, Sandra Sabin.
Sir, please, sorry, I'm here, sir.
So why will it take you forever before you know that you are here? What are you doing that you are not paying attention?
Sir, please, I was pressing the space bar, but I thought
No,
I was
you
audible.
were not paying attention. So you later got to pay attention because I mentioned your name. You should pay attention.
No, sir.
You should be alert.
Yes,
to
sir.
click, stuck to your phone or laptop. First of all, you're not even supposed to use a phone to be listening to me. You're supposed to have your chair, your table ready, resolute, beaming to define yourself in the academic mind. Okay? So nobody forces you. So if you really, really want to do this thing, do it for you. Don't do it for anybody. And I see these things happening a lot every time. And then when students actually don't do well, they say that the lecturer has failed me. But the lecturer never fails you. You define your path and you walk on that path. So please,
I'm
guys,
sorry,
when I
sir.
tell you guys to sit upright, you know, when I was about to start, I was very explicit. Get your notebook, get your pen. I even said, get some water and pay attention. So tell me the answer to the question there.
Yes, sir. Sir, please, we are dealing with shirts, shorts, and pants.
So
our Z function.
I didn't ask you about the Z function. Did I ask you about the Z function?
Sir, please kindly repeat the question again, sir.
Did I ask you about the Z function? The evidence of listening is the results you are actually battling with. Is the evidence of listening. So next time, listen and listen good, okay?
Yes, sir.
You are someone who is in a disciplined environment, aren't you?
Yes, sir. So I am,
I won't
sir.
speak further. I will not speak further. Okay, let's go to David Intikuni.
So your question was, what are we deciding on? So we are deciding on the number of shares to produce per week and the number of shorts and pants to produce per week.
Very good. So why are you using the word number of? So guys, this is how you start your business. Why are you using the word number of, by the way? Oh, David, you didn't plan on answering that.
I didn't know it was directed to me actually, so.
It is.
Yes, sorry.
It's not directed to you, so you can go ahead.
No, can I try?
Oh, don't worry, if your hand is up, I'll call you. David, wrap it up.
Yes, so
So, okay, read me. Yes, read me. So you have the number of shirts to produce, okay, for the shirts. Then you have the number of pants to produce, because we are not dealing with any unit of measurement except the word number of. So that's what you're going to do. And so you can do the same thing, shirts, shorts, pants, and then you can write it. This is the decision variable that you got to do it. And then there is another thing. Apart from this, watch it. Shirt machinery, you need it. It's got to be rented. Okay. Short machinery, you need it. It's got to be rented. Pant machinery, you need it too. And you got to rent that one as well. So all of these, you need them. But here is a clue. If X1, X2, X3 represent the number of shirts, short pants, then we need to understand something here. The first thing is that before I can produce a particular cloth, I'm making it this value. Before I can produce a particular cloth, watch it. If X1 is positive, that's what I've said. Before I can produce a particular clothing type, then I must have incurred the machinery type for that. So Y1 or YI here refers to the type of machinery. Remember that I can be 1, 2, or 3. The fact that Y is equal to 1 means that you must have actually incurred the cost of producing that particular machinery, that particular clothing type before. So if only I am producing, that's an Xi greater than 0. If only I'm producing, then Yi must have been incurred. Now, that means that the Yi or the machinery is only needed. Note that down. The machinery is only needed if I'm going to produce that clothing type. In other words, I only need a shirt machinery if I am going to produce shirts. Do you guys understand? I only need a short machinery if I'm going to produce shorts. I only need a pant machinery if I'm going to produce pants. It is contingent, dependent on the X variables. And because it is dependent on the X variables, it becomes a binary. Because it being there or not being there depends on whether or not X1 has been produced. This is very important. Therefore, we can say that there are 3 other decision variables, which is Y1, which is going to be 1, 0, 1, which is when you're going to incur a shirt machinery, or 0. But the 1 is if X1 is positive. Okay. If X1 is positive, then the Y1 is 1. And the 0 is going to be if X1 is 0. So this is how the binary for the Y has to be documented. And why didn't I call it X's? It's not X's because I don't even know the number of them. Remember the X's, I'm going to know the number of them. But these ones, it is either they are there or they are not there. We are not interested in the number of how many machinery, because all we need is one machinery. One machinery can produce a lot of clothing type. That's all. So if I know that, then we can also say that the Y2 is going to be there, one that is going to be available, present there, if the X2 is going to be realized. That is positive. And it is going to be 0 if the X2 is not going to be realized, and hence it's going to be 0. So even though these are mathematics, you still should understand where I'm coming from and what I've explained. The same way is with the Y thread. Okay? And then on the basis of that, you'll be able to have all of these Ys in a beautiful, beautiful, beautiful way. Let's look at some of them. So these are supposed to be some of these things that we spoke about here. So this is how it is. Here, I've written them in English, but in the slide, in the board, on the board, I wrote it in schematics, which is still cool. You guys are smart. So we have 2 different decision variables. One are the actual products that are going to be produced. The other is the type of machinery going to produce it. And we need to find them. At least we know that the type of machinery is binary. And so those ones, we don't need to find. It's just going to be 0 or 1. But we still need to choose which one it is. The next thing now, knowing these decision variables, is to write your objective function. The objective function is to maximize profits. How do you know that? It was right here. Okay. Formulate an integer programming that will maximize the weekly profit of TTL. How do you do that? Well, since we have fixed charge here, the way you write the profit is going to be different from the one you always know. Profit is given by total revenue minus total cost. You got to follow me. Total revenue is given by something. Who can tell us? This is a good old days. The total revenue is given by something. What is it? Max.
The total revenue will be price times quantity.
Very good. Here, our price is a profit or sales price obtained from the production of each clothing type. What is the sales price here for each clothing type? By the way, you said price times quantity. And then, of course, the other one too is going to be total cost. So what is the price here for this one? Yes, let me see the hands that have been raised. Yes, Matt.
So for shirts, the price will be 12 Ghana cedis.
Good.
And each quantity will be 4.
No, you would not know the quantity.
Okay.
Remember, the quantity here will refer to the decision variable you don't even know. It is the excess. Therefore, you are going to take this 12, but then it's going to multiply the decision variable. Therefore, the price times the quantity is going to be the 12 times the X1. Remember, the shirt is X1. Plus, can you give me the rest now?
Plus 8x2.
Good. 8x2 plus
15x3.
15x3. So in this case, the 12x1 represents the revenue, okay, or the sales revenue obtained from the production of the shirt. Now, we are yet to deal with the total cost. Remember, total cost is given by the fixed cost plus the variable cost. What is a fixed cost here? You can go to this level of the work and you will appreciate that he was very specific about what a fixed cost is all about. Okay. From the story, it says that the machinery type needed to produce each type of clothing must be rented. The fact that it's got to be rented means that it is a fixed charge at the following rates. So we have 200, 150, and then 100. But remember, each one must be incurred if we are going to what? You can tell me. Each of these costs will be realizable, provided what? Philip.
So provided we produce the decision variables.
Correct. Provided produce the decision variables, but also be provided what? Those of you sounds are still up. Chidi.
Provided the decision variables are 1 equals 1, like x1
No, not the
equals
decision variable, not the x's. Provided the y's are 1. In other words, if you don't want to say the y's, provided that the machinery was actually rented. Okay, because if the owner is going to produce the shirts, then the owner will rent the machinery for shirts, which makes the y1 equal to 1. So provided we actually rent it, then the 200 is realizable. So you will not only write 200, because if you write the 200, you are not taking into consideration whether that particular machinery was rented. Remember, the 200 is the expected cost. Once again, it's expected cost. But the actual cost is if the y1 is equal to 1. That is when the actual becomes a 200. Therefore, in writing the fixed cost here, what will it be? You can guess. What will the fixed cost down be? Because it has to take into consideration 2 things. Yeah, the fixed cost is going to be, Philip.
Going to be the cost of renting the machinery times whether or not we will need it.
Good. So the first one will be 200 what?
With 200 times y1.
Good. Then the second one will be what?
150 times y2.
150 times y2.
Yes. Yes.
And the last one?
100 times y3.
Good. Guys, even though we are talking about this, there is still a clause you got to understand. I pray that this thing is not written differently. Are you kidding? Okay. So we are done. Oh, sorry. It's supposed to be y. Now we need to go back and look at the next information, because the next information was, remember that we've taken care of this column here. Okay. This column, the 12, 8, and 15. We've taken care of that. But now we need to go to the variable cost. Variable costs. These are the variable costs, 6, 4, 8. So let's go to the variable cost, because what we've done is we've taken care of the fixed cost. Now we need to take care of the variable cost. And the variable cost was clear. You know, we just saw it. What is that? The variable cost is just 6, 4, 8 for shirts, for shorts, for pants. Okay, so you just write them down. That we are going to have 6x1, because remember they are variables, so they change with the changes in the level of production. Okay, plus 4x2 plus, is it 10? Was it 6 for 10 or 8? Somebody should guide me.
8 says.
8 says.
8.
All right. So now that becomes our profit. It's not difficult at all. You know why? Because you can now group items and simpler. That's all. So you can see that there's 6x1 here and there's 12x1 there. Okay. And remember, it is minus, because remember, if you take this total cost Everything here is minus, 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 minus. So it's going to be minus the whole thing. So who can, and then of course, when you do that, you're going to add the like terms together. So you're going to have 12x1 minus 6x1 and now blah, 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 blah. You do that. Who can walk me now, finally, through the profit function or the Z function? So you can call it Z max. They don't care about how we call it. Yeah, who can walk me through it? Who can walk me through it? Who can walk us through how to now write the final objective function for this variable? You got to follow it here, because if you're not following here, it means that you are going to be a bit over 150 by what is the next thing we're going to do with the constraint. So the first one will be what? 12 minus 6. And that will be 6x1. The second one will be 8 minus 4. That will be 4x2. Then the last one will be 15 minus 8, which is 7. And remember, they are all minus. Okay? So it's going to be 7x3. So this is a revenue part. Then minus, go to the cost. Now remember that we've taken care of all of these. So the only cost we are left with is the 200y1 plus 50y2 plus, 150y2 plus 100y3. Yes, Esther.
Doc, please, I just need a little confirmation. The Z max, 6x2 plus, 6x1 plus 4x2. Should it be plus 7x3? Because it will be 15 minus 8.
Yeah, that's here.
Okay, I'm seeing a minus.
Okay, plus.
Yeah, Doc, it's supposed to be plus.
Okay, thank you.
Okay, I saw another hand. Who was that?
And the X1.
Yeah, I said, please, the 6 should be 6x1. You made this 6x2.
All right, okay. So you guys are following. Actually, I wanted to be sure whether you guys are following. Are you following? So this shows that you are following, isn't it? My trick has worked. I was tricking you. Yeah, it should be.
Sir, please correct me if I'm wrong, but isn't the y equation, aren't they supposed to be negative?
Yes, they are.
Okay.
It was all to make sure that you are following. That's why I'm quietly waiting for somebody to also ask. All right. So it's an indication that you guys are not joking at all. In fact, even if others are joking, because I know others are sitting here, they don't even know what is happening. The whole thing might look like Hebrew. But you guys, it's not any way Hebrew or Latin. As far as you are concerned, these things are purely genius. Okay. Now, so you have plus here, you have plus there, you have minus, you have minus, you have minus. That's our profit. Any question with the profit function? Now you can see that the profit function has got two different decision variables in it. So this is the first time you are seeing a linear program with the two different decision variables. Let's go on. We're going to formulate the constraint. And the first constraint, as you can see there, is going to be about the labor. The second constraint is going to be about the cloth. Remember, we are done with this table. And we are left with that. So now, if you look at the labor, we need to know the right-hand side. If you go to the question, the right-hand side of the labor was here. It's right there. It's in there. So you see that the right-hand side, the labor was 150, and then the cloth was 160. On the basis of that, who can formulate for me? Who can walk me through the formulation of the first and the second constraint? Who will set the stage? Raise your hand and let me know whether you can walk us through the first and the second constraint. Everything you need is inside of you. Everything you need is also on the board. Everything you need is what you need. Everything you need is provided for you. Who will walk us through the first constraint? Abigail Sapon. Abigail Sapon. Abigail.
Hey.
Pay attention. Answer me the question, Abigail.
Sir.
Mm-hmm.
Please, could you go back to the question?
It is the question. The question is what is on the screen. I know it when people are not paying attention. I know it so well. Okay. So next time, pay attention. Dennis Frimpong.
No, the question with the constraints of the labor and then the time.
That's not even what you need first. Okay, if you knew what you needed first, you see that you already have everything. Let me go to Dennis Frimpong. Yeah, Dennis.
Yeah, Doc. So yes, so we have 3x1 plus 2x2.
3x1
plus 2x2
2x2
plus 6x3
6x3
less than or equal to 150.
Less than or equal to
150.
50. So that's a labor constraint. What about a cloth constraint? Cloth constraint. Add lead. Add lead.
Hello, sir.
Tell us a cloth constraint.
Okay, that would be 4x1 plus 3x2 plus 4x3.
Less or equal to 160.
Less or equal to 160.
Good. Now, what other constraint is left? In terms of the storyline, there's no other constraint. But in terms of realities and what we are doing, what other constraints are left? You can tell us. Chidi.
Is it a binary constraint?
What will it be?
Is it a binary constraint?
Are you asking? Are you telling me?
Yeah, someone. So please, is it right? Is it a binary constraint?
Yes, it's not only that one, but at least that's part of it.
Okay. So please, someone should take over.
Okay. So let's go to Michael Anoda.
Yeah, Doc. So x1, x2, x3 will equal to 0 or 1. Good. And then y1, y2, y3 will also be equal to 0 or 1.
Okay. So one of them you are wrong. Who can point out which one he is wrong? Who can point out which one? Of course, you got to know why you think he's wrong instead of saying he's wrong. Robert Panyako.
Sir, please, the Y constraint.
Why?
Because we are looking at the resource requirements, not the revenue and then the cost.
Okay. Roberta, you're also wrong. So who can tell me why what Michael wrote was wrong? Ursula.
Because the Y is a fixed cost and Y is fixed. So it won't be equal to 0 or 1. It will be equal to 1.
Okay. That is also not correct. Nathaniel, which aspect of the formulation is wrong?
I think the sign that he introduced is wrong.
Which sign? The sign for what?
The equal to sign.
Sorry? Sorry, Nathaniel,
Hello.
I can't hear you. Your line is off.
Hello.
Okay, let's go to Michael Barton.
All right, sir. So I think that the binary constraints for the X shouldn't be there. It should only be Y. Because we are making a choice for whether they are using the rent for the plant or the rent for the rent for the plant for the sheds or the rent for
No. You said what shouldn't be there?
XI shouldn't be there. XI greater than 0 or 1 shouldn't be there.
But it should be what?
It should be YI greater than.
No, you said XI shouldn't be. And I said it should be what? Now you're changing to Y.
It shouldn't be there. The binary constraint shouldn't affect
be?
XI greater than or equal to 0 or 1 shouldn't be there. It should be there as a non-negativity constraint, but they're not there as a binary constraint.
Okay, so how would you write that? That's what I'm saying.
All right. So I'll write XI greater than or equal to 0. And I also come to the second line writing YI greater than or equal to 0 or 1.
So the YI greater or equal to 0 or 1 is correct?
Yes, it's correct.
But then the XI is the one that was wrong.
Yes.
Perfect. That's the answer I'm looking for. You see, it's one thing knowing the answer, it's the other thing transferring the knowledge out. So this is how it's supposed to be. The XI can be 100. Remember, we said the number of sheds to produce is not a binary. The decision variables for which are X are not binary. Because once you get that machine, you can produce as many sheds as you can. Once you get the machine for short, for pants, you can produce as many number of pants as you can. And that is a point under consideration. So take note. So the non-negativity is for only this, but this one is for the binary. Okay. Now let me show you something now. Let me show you everything that we've done.
No, can you come again with what you just said? I didn't get you.
What I said is that as long as you incur, okay, the cost for the machinery, once you get that machinery, it means that you're going to produce that type of clothing. And so the number of shirts, shorts, pants, which is the excess, doesn't matter what number, you will still produce that number because you already now have the machinery. Okay. So that one is not limited by any non-negativity constraint. Those who don't listen, like Eugene, they are the ones who tend to disturb. So the non-negativity are the ones that actually is, the non-negativity constraint is for a constraint that is bad. See, even though the guy said what he said, there's something he made a mistake on, and I need to correct that. Who was the guy who was explaining beautifully plenty? You said that, you missed something. You should simply have indicated that the XI should be integers.
Okay.
You get it?
Yes.
So it is XI greater or equal to 0 and integer. They are integer constraints, but they are not binary constraints. They are integer decision variables, but they are not binary decision variables. So coming back to your question, Opede, your question was that you wanted to understand. You wanted to understand because the x's are different from the y's. Watch it here. These are the x's. The x's must be integers because you want shet to be not decimals. So they must be integers. But then the y's are binaries. The y's, you don't need a number of them. You just need need them to be there because they are big machines. You need them to be there or not being there. And they being there is 1. They not being there is 0. And therefore, there is no way you got to attach non-negativity to them. It's only binary. Because non-negativity takes you far. But for the x's, yes, you can apply the non-negativity. But also don't forget, those ones must be whole numbers, hence the integer. This is the final formulation you see on the screen. If you solve this formulation, is it going to be correct? Of course, by me asking you this question implies that I'm assuming or I'm telling you that it's not going to be correct. So my question rather will be this. Who can tell me why, even though this formulation was done by us, is wrong? Okay, let me tell you why. Let me give you a clue. That will give you a clue why it is wrong. So I solved this formulation in Excel. I've done it already, and this was the result I had. What is the problem with this result? Look at it carefully and tell me the problem with this result. Who can tell us? Who can tell us? Who can tell us? Philip.
Sir, I think the problem is, I think when we looked at the constraints, we couldn't see any of the.
No. I mean, look here, and tell me this solution here. Don't change things because you have an idea from the slide. Follow my question. Look at this very result here. Tell me what is the problem with this very result, not what you think somewhere else. Are you seeing the fact that I'm helping you to come back to reality?
Yes, sir.
Okay, so tell us.
The problem here is x2 is the same as y1, y2, and y3, which is 0.
Okay, and that's a problem.
Yes, sir.
Okay. What you should have done was to tell us why that's a problem. See, he wasn't prepared for that question. That's why he's now fidgeting there. Barbara.
So I think that if y1 is equal to 0, there's no way that we'll have x1 being equal to 30 because it is dependent on the fact that the machinery has to be present or available.
Correct. What other thing? You can tell us another issue. Isaac.
Yeah, Doc, the same applies to Y3. If it is 0, then X3 cannot be 10.
Correct. So there is an issue. Which one is correct, at least in this example here? Which of the solution here is correct, at least in this example? Esther.
So x2 being equal to 0 and y2 being equal to 0 is correct.
Fine, excellent. So now let's try to see why this cannot be. Okay, and the reason is because it did not take into consideration. You see, when you look at the objective function has got y's in them. And so when it comes to the constraints should also have y's in them. Unfortunately, the constraints are not having y's in them. And that is where there's a problem. The problem is that once you have the constraints, the objective function, having machinery content, because there is a link between the machinery and that of the decision variables. There is a link between producing a shirt and using a shirt machinery. Because here's the point. If you are producing a shirt, mathematically, this is what I mean. If xi, it can be any of them, is positive, okay, you are producing it, then it means that, it implies that the yi is also 1. That's what it means. And also, if xi is 0, because it can be 0 or positive, okay? If xi is 0, then implicitly yi must be 0. We know this already. Therefore, there is a connection, that's the word, link, between the x and then the y. What is a link? We are going to use a trick. Say trick. Say trick.
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 Trick. Say some. Trick. Gary, yes.
Trick.
Stop saying it. Somebody is now saying it. We're going to use this trick to link x and the y, to link the decision variables and then the fixed charge. And this trick is given by this xi, every xi is less than or equal to, every xi, I want to write it down, is less than or equal to mi yi. I'm imposing something on you, which has already been imposed, but I'm going to explain to you why this link is important. Now, what values can the y take? You can tell me. What are the possible values the y can take? This y alone. Michael.
0 or 1.
Okay, so let's start with that. If this y is 0, then the whole of this thing on the right-hand side here is 0. And that will mean that x is 0. So if it is 0, we are done. Finished. Job done. And the next value y can take is 1. If y is 1, then the x value, remember the symbol is less than or equal to. The less than will mean that there are several values below the m. But then the equal to means that the x will be equal to the m. And therefore that m will be the biggest value that x can take. In other words, because it's less than or equal to, the less than part means that there are some numbers below the m. Now let's assume that m is 50. And then we were able to find out that y was 1. If y was 1 and m is 50, then it means that there are so many numbers, the less than part means there are so many numbers below the 50. Which also means that the highest value that this x can have is what? Tell me. It means that the highest value this x can have is what, Esther?
50.
50. Okay, by the example I just gave. Therefore, what is m? You can define m for us. What is m? I've said it twice. So what is m? Because 50. This m is going to give you the link. M is actually one of the x's. Take note. But it is what kind of the x's? M is one of the x's. But it's what kind of the x? Not.
So please, the upper bound of the x.
Thank you. Is the upper bound of the x. And guys, go and check some of the past questions. You are always asked to calculate that upper bound of the x. Therefore, we are now ready, ladies and gentlemen, to calculate the upper bound of the x. Michael, you have a question? Or you were singing?
No, Nat already said it. Sorry.
Okay, all right. Okay. So now let's go and calculate the upper bound. But before we do that, let me just show you something very quickly. I'm going to write these for each one of them. For each one of them, I'm going to write it for you. And I'll clean it, of course. So we are going to find x1 less than or equal to m1 y1. We're going to find that. We're also going to find x2 less or equal to m2 y2. We're going to find the value of m2. Then we're also going to find x3 less than or equal to m3 y3. In all of them, what we are doing is that we are finding the m's. Why? Because the m's will give us the upper bound, the highest value that the x's can take. The x's can take it. So we are going to start with the m1. And in doing that, the only way to get the value of the m1 is to solve it, find it from all the constraints. So these two constraints, these are the two constraints that we are going to find. If the constraints are 7, we'll use all the 7 constraints to find the m1. Then we'll come and use all the constraints to find the m2. Then we're going to use all the constraints to find the m3, where the m is the highest value that the x can take. So let's start with the m1. If we are going to find this m1, let me call it m1. I'm going to find this m1. In that case, since the focus is on the m1, I do not need the x2 and the x3 in any of the constraints. I want to repeat. Because the focus is on the m1, I am looking for the highest value of x1. That's what I'm looking for. And because I'm looking for the highest value of x1, I don't need the value x2 nor x3. Also, because I'm looking for the highest value of x1, this symbol should change to equal to. Because remember, I'm looking for the highest. And so I don't need the less than part. I need the equal to part. So ladies and gentlemen, I'm going to take each of the constraints. And for each of the constraints, I'm going to assume that the x2 and then the x3 are 0 and solve for the x1. So let's start with the labor constraint. In this labor constraint, if this x2 is 0 and this x3 is 0 and this symbol is equal to, then what will be the value of the x1? Simple equation. Yes, Nat.
Let's see, with 3x1 equals 150.
3x1 equals to 150, which means that x1 is what?
So
50.
I'll divide it
by 50.
50.
Yeah.
Now we go to the second constraint and do the same thing and find another x1. So when you come to this second constraint, the x2 must be 0, the x3 must be 0. If this one is equal to 160, then we are left with the 4x1 equal to 160, which means that the x1 is equal to what?
40.
Is that what you wanted to say, that you are talking plenty? What's our saying?
Yes, please.
Now that you got a clue, you are jumping them. Okay. So we have 2 different x1s. Remember, if the constraints were 7, we are going to calculate 7 different x1s. And which one should we take? Take a good guess. And the first answer that came to your head is wrong, by the way. So take a good guess and tell me the answer. Esther. Esther.
I was going to say the highest, which is 50.
And that is also why I knew that. And because I said that that one is wrong, you were now confused, which is true. That will be wrong.
Oh, okay.
So the best answer is what? If that is wrong, then the best answer is what? Is a 40. Yes. So 40 is the right answer. Why should it be the low? And by the way, the rule is that the lowest value of the two x's or the two x's is always the maximum value of m of x. The lowest value is always the m. That's the point. Why? Why? And this is why. In order to confirm this, yes, Philip.
So I wanted to explain why, but
okay, explain. I like it.
So we will choose a lower value because when you substitute that value into the two constraints, it satisfies both constraints.
Good, excellent. You're right. So guys, what he said is perfect. If you take the 50 and you drop it into this two constraints, the first constraint will give you 3 times 50, which is 150. That will be fine. That will satisfy the labor constraint. But if you drop the 50 into the 4 times 50, that will be 4 times 50 will be 200. And that will be above the maximum of 160. So it will not satisfy. But when you take the 40, you multiply the 40 by the 3 by 1 by x. So that's 3 times 40. That will give you 120, which is less than 150, which satisfies the constraint. And then the second one to 4 times 40, which will be 160. And that is the same 160 on the right. That will also satisfy the constraint. So always choose the lowest value to represent your m value. Therefore, let's go back to our equation here. Okay, this equation. We are going to rewrite the whole thing and replace the m1 by the 40. So we get x1 less or equal to 40 y1. That's it. So we've been able to find the 40, which is the highest value the x1 can take. Can you do the same thing for the m2? Please, I want you all to work. And then you tell me the first answer. So in the m2, you are going to consider the x's, the x1 and then the x3 rather as 0. And solve for the x2 in both cases. And then I will ask you which one is the m2. And based on which one you saw to be the lowest value, you give me the answer. So in the first constraint, what was your value of x2? You can tell me. Raise your hand and tell me. In the first, if you worked it by yourself right now, okay, what was your first value of x2 in the first constraint? Raise your hand and then tell me. Not.
Please, 75.
Good. So the first x2, let me write it here. Okay. So Nat says that his first x2 was 75. Okay. Now, the second x2, who will give me the second x2? Michael.
It's 53.
It's 53. No, it's not 53. The second x2 is not 53. Let me see somebody. Dennis.
53.3333.
All right. 53.33. Michael, I know why you didn't bring the decimal. You were rounding up, isn't it?
Yes, Doc.
But you know, from the beginning, we said that we don't do rounding ups here. You remember, this is just part of an equation. It's not a solution. All right. It's a solution that should be integer. It's not this part of an equation. All right. So on the basis of this, we will take the last one, which is the 53.33. So how would you write the second linking constraint? How would you write it? How would you write that? Since you now have all the values. Yes, Nat.
Okay, so say please, I will take the lowest value first, which is 53.33. Then substitute it in x2 less than or equals to, which will be 53.33 y2.
Good. So this is how it's going to be. And that is the second linking constraint. Who can give us the third one? X3 for the first equation. What was it? For the third equation. For the third one, the first constraint. And then somebody will also give us the second constraint. The first constraint, David. David in Tukuni.
25.
25, okay. And then the second one?
The second one is 40.
Sorry?
The second one is 40.
40, very good. So who can walk us through the last linking constraint? The last linking. Okay, say it and I'll write it down for everybody. Nat.
Okay, so sir, please, I'll take the lowest value, which is 25, and substitute it in the last constraint, which will be x3 less than or equals to 25 y3.
Good. So now we've been able to get all the linking constraints. That's all. Then we take them back into the original model. And this, ladies and gentlemen, is what becomes the final model of the linear programming. After you've done everything I've said is in the slide, so you can take your time and go and check all the slides. So this is what you get. You can now see from this model that your objective function is there, your labor and cloth constraints are there, the linking constraints, all of them are there. Please do not look at the 53 here. It's not supposed to be there, it's supposed to be 53.33. And then the usual integrality constraint for the x's are there. The non-negativity constraint is there, and then the binary constraint is also right there. Because you have been able to define this, I solved this one too in Excel. You can actually easily model this in Excel. And this was the result I found after modeling everything in Excel. Ladies and gentlemen, this was the result. Does this result make sense? And why? Does this result make sense? And why? This result, does it make sense? Is it sensible? Is it truly optimal? And why? Why? Mimi, are you there? Can you tell them why it's optimal?
Yes, Doc, I'm here.
So tell them why it makes sense to them.
It's because the y3 is 1. So it means when we get the y3, if y3 is equal to 1, then it means that we are going to use the machine of y3 to produce the 25. The 25, the shirts.
Yes, the shirts.
Yeah. The
So
that's why
cancellable, not
producible.
pants.
Yeah.
X3 was pants.
So you can see
So
that.
it means that we are going to produce 25 of the pants.
So what is your advice you will give to the manager of TTL, Imi? What advice will you give to the manager?
So I would advise the manager, in order for him to maximize profits, he should get the machine for producing the pants so that he'll be able to make a maximum profit of 75 Ghana cedis.
And I should not do what?
He should not get the machine for producing shirts and then the shorts.
Why?
Because those ones wouldn't earn any profit.
Good. Because they will not give him the maximum profit if he should ever get them at all. So all the hula baloo about a company, they just have to produce only pants. That's all. That's it. Guys, of course, I will not ask you to do this thing in Excel, okay, under exam condition. But under exam condition, you will write it. Remember that when you look at the constraints here, there were just two, labor and cloth. So imagine the constraints were 4. You have to find the max M1 for all the 4, and then choose the lowest one. You find the M2 for all the 4, and choose the lowest one. You find the M3 for all the 4, you know. It is finding the M's. That is what takes time. Of course, you can see that this linking constraint, I just moved the right-hand side to the left-hand side, so that I'll have 0 on the right-hand side. This was just so that I can do easy Excel formulation. There's another one in the slides. You can check it, and you'll see it. Anyway, this is how I did the Excel formulation. You can check it, and then do it yourself later, so that you know that you are on the right track. Ladies and gentlemen, that brings us to the end of the entire caboodle. What a day. There's another example there in the slides. You should check it, and then you can enjoy your moment of stay. Michael, you have a question?
Yes, Doc. So this is to take us back a bit. In our last linear programming discussions, I seem to have some confusion with regards to the sensitivity range. I recall in the first example we saw, you mentioned that the sign is less than or equal to. But in another example, you mentioned that it is just less than. So I wanted clarity.
So we established it. Use the less than, not the less than or equal to.
All right. Okay. Thank you very much.
Okay, Nat, you have a question? Nathaniel.
Yeah, say please. What I want to know is that, so meaning that anytime I get X3, or anytime I get maybe Y being equal to 1, it means that I can move on with production, and without being 1, 2, I can maximize or minimize. I can maximize profit or minimize costs.
Yeah. Yeah.
Okay. Okay.
All right. So, ladies and gentlemen,
please,
see,
thank you.
The best way is to try your hands on some of these questions. Like I said, the constraints can be more, the decision variables can be more than the 3 that we had. We had X1, X2, X3, there can be X4, X5, but the principle is the same thing. Drink deep or taste not the Pyrean spring. Their shallow drought will intoxicate your brain, and drinking largely will sober you again. Remember, knowledge is the only asset that creates all other assets. Okay? If you are hungry for knowledge, you will never lack. Hosea 4 says, lack of knowledge, my people perish. Not Satan's people, my people perish. So you got to be hungry for knowledge. You got to love to learn, because learning is a foundation of anything. Anything.